Okay, so in redox reactions, as the name suggests, if you look at the name itself, it speaks for itself. So you speak up the word and the topic is done. It's like rid-ox. Rid means reduction and ox means oxidation. So both reduction and oxidation, the reactions which take care of both reduction as well as oxidation are known as redox reactions. Alright, so generally this is what you've done before also. You should know first of all what is the difference between oxidation and reduction. Okay, as the name suggests, oxidation. So addition of an oxygen means that whenever you talk about an addition of oxygen, that means you're talking about oxidation. And oxygen is getting added up, so it's oxidation. All right. Whenever subtraction, so removal of an oxygen, then that means it is reduction. Okay. Then so it is like subtraction of hydrogen, entrance exam ke liye shortcuts. So and then you have addition of hydrogens. So sometimes you just look at the reactions and you say whether it is reduction or oxidation directly by looking at the reaction itself. Alright, another there may be some molecules in which hydrogen and oxygen are not involved, but still they are getting reduced or oxidized. So in that case you talk in terms of electronegative or electropositive elements. Now electronegative elements are the ones which have a tendency to gain electrons. Electronegative, they have a tendency to pull the electrons towards themselves. So oxidation means addition of oxygen is electronegative. Oxygen is electronegative. So if I talk of addition of an electronegative element, so then that means oxidation. Okay? Addition of oxygen or an electronegative element means oxidation. This is just the opposite. So subtraction of an electronegative element. Please take the usual meanings of these short forms. Not allowed for your subjective examinations at all. A teacher will not understand whether that this means an increase. Please do not put this. Many students have the habit of putting it in the subjective paper even when you come to the graduation and post-graduation level. Which is like, how do we know that this arrow is going up in the air or it means an increase? So please do not use such symbols. It's only for your short notes. So addition of an electronegative element. Similarly, if addition of an electronegative element means oxidation, removal of an electropositive element would mean oxidation, and addition of an electropositive element would mean. This is like very elementary definition that you have already done before in 10th standard probably. Oxygen getting added up means oxidation, oxygen getting removed means reduction, hydrogen getting added up means reduction, hydrogen getting removed means oxidation, and you have similarly you can link electronegative to your oxygen and electropositive to your hydrogen. Let's see some very basic simple examples. Try and go slow with it because it's an enjoyable topic, and as I told you, as I tell you the name redox, the topic is done. You talk about reduction and you're talking about oxidation. You all know the meaning of reduction and oxidation. Alright, we can take up some reactions, some very basic reactions. Alright, here we have. Okay, just look at it. No need to write them. These reactions are available. You'll find what you're doing in chemistry is all about reactions. Pick up any reaction and start thinking about whether what is getting reduced and what is getting oxidized. It's fun doing it and it's very simple. Just look at it. Just look at it. H2S plus Cl2. Okay? H2S plus Cl2 is forming HCl plus S. So what is happening? H2S is losing its हाइड्रोजन here. H2S से क्या हुआ? देखो H2S का H2 तो अलग हुआ नहीं, सल्फर हुआ अलग. So from the very basic definition that you've done, so H2S is getting converted to simply S. So that means hydrogen is getting removed. So that means this is getting oxidized. Oxidation is happening to your H2S. So if you simply look at the molecule, you say H2 got removed, and if your H2 gets removed, then it's oxidation, right? Then for Cl, for Cl2, H got added up. So that means this is getting reduced. So you say reduction of Cl2 is happening and oxidation of H2S when you look at the molecule itself. ठीक है? इस केस में because some of you may say here H2S is getting converted to HCl. No, because you have H2 and S as separate entities. You have two atoms, hydrogen and sulfur, and that's getting converted to sulfur. So you say H2S is getting oxidized, right? I give you another example, and then you tell me you have Fe3O4, all right, plus 8Al. In this case, you get 9 Fe. I mean, you can just balance it out. I'm not talking about the balancing part of it right now. Plus 9 Fe means this must be 3. All right, 9 Fe plus 4 Al2O3. Now, just simply by looking at it, reduction oxidation is happening because we are talking about redox reactions. So you have Fe3O4, it is losing its oxygen. So clearly it means that Fe is getting reduced, Fe3O4 is getting reduced because it's losing its oxygen. And Al is now having extra oxygen now added up, whatever molecule it is. So you will say aluminium is getting oxidized and your Fe3O4 is getting reduced. Clear? Because oxygen is getting removed from it. Any doubts to anyone? If you want to write these reactions, you can. But then I think these must be given in your book as well. Okay, let's talk about more things, some one or two more reactions. Say if I am talking about now, if I talk about the same concept and I say that now you have Na, all right, 2Na plus H2, okay, 2Na plus H2 is forming 2NaH. So, as per what you've done in the previous grade, is like if hydrogen is getting added up, it is called reduction. But in this case, I am saying Na is getting oxidized and H2 is getting reduced. बात समझ में आई? For many examples, it is like absolutely appropriate to say, like in this case, H2S may say H2 got removed. So we stated that H2S is getting oxidized because hydrogen got removed. Sulfur, chlorine mein hydrogen is getting added. So we stated it is reduction because hydrogen is getting added up. Now in Fe3O4, oxygen got removed. So we said it is reduction. And for Al, we stated because oxygen is getting added, it is getting oxidized. Now if you look at this reaction where you have sodium reacting with hydrogen, now hydrogen is getting added up. So it should be the case where you should say that sodium is getting reduced. But a careful examination shows that sodium is getting oxidized and hydrogen is getting reduced. So that means just by looking at the definition, that is not sufficient. So we need to look at something more. And that something more will be in terms of loss or gain of electrons. Loss of electrons or gain of electrons, because we'll find out what is losing and what is gaining. Loss of electrons or gain of electrons. Now see, what do I understand by loss of electrons? These are very elementary topics, so I am discussing each and every bit of it. If I talk about loss of electrons, means that, see, one thing that you can remember, I'll talk about oxidation number. Oxidation number is like some number which is given to each element. And that number is like 0 in its pure form, pure state. जैसे अगर A है, ठीक है, A now is becoming an ion. You have seen this reaction so many a times. For sodium, for magnesium it becomes Mg2+. तो अगर ये A is becoming A+, ठीक है, plus an electron, तो I will call this loss of electrons. बात समझ आई? This is called loss of electrons. मतलब whenever you have electrons on the right hand side, it is always called the loss of electrons. And if I have to talk of gain of electrons for the same element, I will say A plus electron is giving A minus. So this is gain of electrons. So that means when my electrons are on the right, that means there is loss of electrons, I will call it oxidation. So remember always oxidation refers to loss of electrons. जब भी electrons right में दिखें तो क्या हो रहा है? Oxidation. Now in terms of redox, whenever you see electrons onto the right, what is happening? Oxidation. And whenever you see the electrons on the left hand side, you know electrons are getting gained, and we call this reduction. So now apart from you must have written 4 things that I wrote on the board. Addition of oxygen means oxidation, removal of hydrogen means oxidation, addition of electronegative element or electronegative element means oxidation, removal of electropositive element means oxidation, and loss of electrons means oxidation. At that point, loss of electrons means oxidation and gain of electron means reduction. Okay, so now if I have to talk about this, then clearly I will clearly state the rules of the oxidation number, but before that just look at it. This A will be taken as a 0 state, pure state as 0 oxidation number, and now it is going to +1 oxidation state. So whenever your oxidation number increases, then also oxidation, and whenever the oxidation number decreases, it is reduction. Add another point. Increase of oxidation number means oxidation, decrease in oxidation number means reduction. So here it is going from 0 to +1, and here it is going from 0 to -1. So let me just take up an example for this. So there was a need for to talk about some other concept apart from losing and gaining of just elementary electropositive and electronegative elements and hydrogen also. Like this is your, in fact, our favorite molecule which we've talked of in all the topics, 2Na plus Cl2. Okay? This what is the, now going back to the concept of inorganic chemistry that we've done, 1s2, 2s2, 2p6, 3s1. भूल गए? आवाज नहीं आई. This is like sodium is 11. Sodium is 11, so 1s2, 2s2, 2p6, 10 and 3s1. So then for chlorine again it is like, chlorine is 17. So it is like p5. It will be p5, 3p5. Sulfur chlorine. So 17, it will be 3s2, 3p5. Yellow. Happy? So now in this case, you know that this needs 1 electron and this has to give 1 electron. So that means this will be giving electron and losing an electron. Losing an electron means it will get oxidized. So that means Na will now get oxidized. It will form NaCl. So that means Na will be getting oxidized because it is losing electrons. Now this is from your previous knowledge, जो अभी तक पढ़ा है. You know that ionic compound is formed by the transfer of electrons. So this is completely giving the electron and that is completely taking the electron. So if this is gaining an electron, that means it is getting reduced, and this is giving an electron, so it is getting oxidized. Got this point? So similarly, if you talk about Na, so by looking at the configurations also you can just say, but we'll come to an easier point which is far more quicker just in a short while. Like you have Na plus O2 now. Let's talk about it. This is like 3s1 and this would be 2p4. Again, this is capable of taking 2 electrons and that is capable of giving 2 electrons. कैसे? 2 Na चाहिए उसके लिए, right? So in this case you will have the compound that gets formed. In fact, you will have 4 Na here because the compound that gets formed is Na2O, or either you take it as half O2. Half O2 means 1 and 1 O means it needs 2 electrons. 2 electrons it is getting from, getting the point, if you have 2 oxygen atoms then that will need 4 electrons because har ek ki configuration will be 2p4 2p4 and you need to make it 2p6 2p6. So in this case we'll have to take up 2 electrons for 1 oxygen atom if I balance it, and this will give up 2 electrons that are required by it. So this is losing electrons. How many? 2 electrons. So Na will show up loss of 2 electrons. That means it is getting oxidized, and oxygen is taking up 2 electrons. So this is getting reduced. That is because of gain of 2 electrons. Clearly, here also, let us now look at it. You have this as 3s1 and this as 1s1. Right? We've used only one of the hydrogens here and one Na in the final molecule. That's easier to look at. Now hydrogen is capable of taking 1 electron more easily in comparison to sodium, because sodium का octet तो फिर भी नहीं complete होगा. Even if sodium takes 1 electron, it will become 3s2, but octet तो नहीं complete होगा. But for hydrogen, you know that the outermost shell only needs 2 electrons. So hydrogen will take up an electron, so that means it will gain an electron, right? And if it is gaining an electron, it will get reduced, and Na will get oxidized because it is giving an electron. So that is another forefront to it. I have given you another outlook to your oxidation and reduction. Clearly, you have, by just looking at the configurations also, you can actually state which is giving and which is taking. Then the best one is like you can talk about the oxidation number, calculation of the oxidation number. So there are certain set of rules. Like one of the rules I stated that whenever you talk of a pure element or a pure state compound, then in that case the oxidation number is always 0. O2 में O का oxidation number is 0. N2 में N का oxidation number is 0. Helium is 0. Hydrogen H2, H in H2 is 0. So that ways whenever we talk of oxidation number of any pure state. So let me just read out the calculations. Oxidation state of all the elements in their elemental state is taken as 0. Just make a note of H2. Examples note kar lo so that you remember the point from there itself. Oxidation state of each of the elements in Cl2, F2, P4, O2, Fe, H2, N2, oxidation number in all these cases is 0. Okay? No need to write down the words of each and every statement. Next, common oxidation state of group 1. What is your group 1? Lena? Yeah, Helena or Lena, whatever, kabr se farar. What? You have lithium, sodium, potassium, rubidium, cesium, francium. All these have an oxidation number of +1. Clear? They will have an oxidation number of +1. So group 1 with +1 oxidation state. Written the second, you don't have to write full sentences, I am telling you again. Just write short notes. First point was that pure state elements have a 0 oxidation number. Second, group 1 will have an oxidation number of +1. Group 2 similarly will have an oxidation number of group 2 +2 +2. Alright. The third point states for ions composed of only one atom, the oxidation number is equal to the charge on the ion. For ions like for example, if you have S2 minus, so what is the oxidation state of sulfur? It's 2. If you have P4 minus, so what is the oxidation state of phosphorus? 4. Simple. So I repeat the point. Just write down an example. S2 minus has an sulfur has the oxidation number is generally taken as -4. So that will be -4. Because when we look at it, it will come like that. Okay? Clear to everyone? Then I will read out the next point. This point I will repeat it. For ions composed of only one atom with a charge, that charge is your oxidation number. Clear? Next point. The oxidation number of oxygen in most compounds is -2. Right? Except in case of peroxides. Peroxides are like H2O2. In that, oxygen will have an oxidation number of -1. Because oxygen is something that you will find in most of the molecules. So it is important to remember. Like for example, while in peroxides, so in water, what is the oxidation state of oxygen? -2. Why? Because this is hydrogen to +1 या -1 कुछ भी हो सकता है depending upon what. this will be like, if you could take it to be +1 initially, कैसे निकालते हैं oxidation number, I'll explain. This will be, hydrogen is +1, 2 hydrogen है तो कितने हो गए, +2 plus x is equal to neutral molecule है तो charge कितना हो गया total 0, x is equal to -2. So generally in water your oxygen's oxidation state is -2. But when you talk about in case of H2O2, take H to be +1 and calculate, it will be +2 plus x मानोगे oxygen को, so plus 2x is equal to 0. So 2x will be equal to -2 and x will be equal to -1. So in peroxides like H2O2, so the moment you see the peroxide, you don't even have to think. Oxygen will have an oxidation state of -1. Alright, another thing, in superoxides like KO2, RbO2, in superoxides like KO2, RbO2, each oxygen is assigned an oxidation number of -12. So in case of superoxides, you have the oxidation number of oxygen as -12, and you can calculate also. अभी last rule में हमने पढ़ा potassium will be lithium, sodium, potassium group 1, so it will be +1, ठीक है, plus 2x, ठीक है, x will be for oxygen because oxygen का we are finding out the oxidation number, so +1 plus 2x, the overall molecule is neutral, so that will be equal to 0. So 2x will be equal to -1, x is equal to -12. So in superoxides, the oxidation number of oxygen is taken as -12. So let's discuss in water or generally most of the compounds, oxygen will have an oxidation number of -2. In peroxides, it will be -1, and in superoxides, it will be -12. Okay, next, in oxygen difluoride, OF2, this was a question that we had done before. Why is OF2 called a fluoride and not an oxide? Because जहाँ जहाँ पे oxygen है, we always call it an oxide. Alright, but Cl2O or anything else, we call it Cl2O, Br2O, we call it the oxide. But here in case of OF2, we call it a fluoride. Why? Because fluorine is more electronegative than oxygen. Then in oxygen difluoride or dioxygen difluoride, O2F2, the oxygen is assigned an oxidation number of +2 and +1. +2 and +1. Because oxygen and hydrogen are mainly important. The entire redox that you've understood till now is in terms of giving and taking of oxygen and hydrogen. So here you have oxygen, take it to be x -2, because why? Fluorine is -1. Fluorine is what? -1, and so it will be x -2 is equal to 0, so x will be equal to +2, and here it will be 2x -2 is equal to 0, so x will be equal to +1. So for oxygen we have done in majority of the cases, like oxygen fluoride and dioxygen fluoride, you have +2 and +1. Okay, then we have the oxidation number of hydrogen is generally +1. The hydrogen in the molecular form. If you have if you have H2O or you have H2SO4 or you have an HCl, in all these acids, please note down these examples because I don't want you to write down points. Point wise, write down the examples. So next, in the next point, you can just note down that hydrogen is generally assigned an oxidation number of +1. So hydrogen +1 for HCl, H2SO4, H2O, etc. But in metal hydride, it will be assigned -1. In metal hydride means sodium hydride, magnesium hydride, potassium hydride. In all these cases, it will be assigned an oxidation number of -1. Okay, fluorine always -1. Next, fluorine will always be -1. The sum of all the oxidation numbers for a neutral compound will be, I've already shown it, will be 0. the sum of all the oxidation numbers will be 0. In a particular neutral molecule will be 0, or a compound, because compounds are neutral. Otherwise I will call it an ion. Okay? So the oxidation, the total oxidation number, or the sum of all the oxidation numbers of individual atoms in a molecule or a compound will be 0. Okay, in a polyatomic ion, the algebraic sum of all the oxidation numbers of atoms of the ions must be equal to the charge on the ion. That is like if you talk about, say, NO3 minus, okay? In NO3 minus, now oxygen is not in a peroxide state, so it can be taken as -2. That is why we have done it for oxygen. In peroxide it's -2, in peroxide it's -1, in superoxide it's -half, in OF2 it is +2, and in O2F2 it is +1, and otherwise in general all it is -2. So if we take it to be whatever, say nitrogen का अगर निकालना है इस केस में, so consider nitrogen to be x, ठीक है, oxygen is -2, so -2 into 3 is 6, that will be now equal to the charge on your polyatomic molecular ion, that will be -1, so x will be equal to +5. Clear? +5. Before I give you more examples for the oxidation number, let's move back to the reaction which made us do something extra. What was that? Na plus half H2. इसका हमने बोला था ना that this is actually forming NaH. So it is not addition of hydrogen that you will look at, because if you talk about addition of hydrogen, तो आप बोलोगे no, sodium is getting reduced because it's adding up a hydrogen atom, but which is not the case. So we needed to look at something extra. So then I explained in terms of electronic configurations that you have 3s1 here and you have 1s1 here. So this is losing electron, so this is getting oxidized. This is gaining electron, so this is getting reduced. Why? Because here the oxidation number is 0, here the oxidation number is 0. Now here it is giving 1 electron, so +1, and it has taken up 1 electron, so it is -1. And moreover, in metallic hydrides, your hydrogen will always have an oxidation number of -1. So from here 0 to +1, 0 to +1 means increase in oxidation number, so Na is getting oxidized. 0 to -1 for hydrogen, so that means hydrogen is getting reduced. Got the point? Now let us take up some examples. Find out the oxidation number for chromium in K2Cr2O7. Alright, let's try it out. Now, you find out the oxidation number of the underlined atom. Okay, work it out independently, aram se, there's no hurry. It will be Cr2O7, then, okay, KMnO4, alright, then, okay, HClO4, H2, central atom only, H2SO4, KClO3. I myself haven't worked it out, so it will just take about a second or two. Shouldn't be taking much time. Alright, you have Cl2, so S8, sulfur in S8, P4, okay, P4O10, I'll give you more, then Na2, S4, Na2S4O6, H2, SO5 CrO5. What we are doing is finding out the oxidation number. Now I hope you know how to find out the oxidation number. Remember that the sum of all the oxidation numbers will be taken as 0. It's a neutral molecule. I haven't given any ions till now. So CrO5. Then you take up the example of NH4NO3. Okay. Quickly, I'm just giving you exactly 2 minutes to do it. All of them. It's a child's play. One minute left. Can we discuss now? Time's up? No, just 10 seconds more. Up now. Look up. K2Cr2O7. Just solving it. 2x plus, your Cr, take it to be x. Whichever is underlined, take it to be x. You know potassium belongs to the first group, so plus 2 minus 14. Why? Because 7 2s are 14. So it is like minus 14, which will be equal to 0. So this will be called as, this will be actually x will be equal to plus 6. You can easily find it out. Next, for the case of KMNO4, it will be plus 1 plus x minus 8 is equal to 0. So x is equal to plus 7. Clear? Next, we have in HCl4 plus 1 plus x minus 8 again, right? It's HClO4. So minus 8 again. So that is equal to 0. So this implies what? This x will be equal to 7. Next, H2SO4, one of your favorites, that's like plus 2 plus x minus 8 is equal to 0. So sulfur means, for sulfur here it will be plus 6. Sulfur will be plus 6. Next, for KClO3, plus 1 for KClO3. Do you want me to write down the molecules also simultaneously? So for KClO3 we have plus 1 plus x minus 6 is equal to 0. So this implies x is equal to plus 5. So 0 0 0. So you become a hero. So you have P4 in O10. In that P4 means plus 4x minus 20 is equal to 0. This implies X, this is for P4O10, I repeat, this is for P4O10. So your X will be equal to plus 20 divided by 4, that's 5. So phosphorus is in plus 5 oxidation state. Now 10 by 4, very good. Why? Because in this case, now look at this particular molecule, Na2S4O6. You are ignorant about the structure of Na2S4O6 because we haven't done it, and I know you haven't done it. So there are two ways of looking if the structure is given. One, you can always check it by the simple way, plus 2. I am talking about Na2S4O6. Look up, time's already up. Why are you writing? Plus 2, okay? Plus 4x minus 12, 6 2s are 12, 0. So your x will be equal to 12, so that becomes minus 10. So 10 by 4. 10 by 4 means 5 by 2. So you can just actually state 2.5, 5 by 2 or anything. There is another way of looking at it. Sometimes in many of the cases you will be given the structure of the molecule and you will be asked to predict the oxidation number. So उस केस में जैसे generally you look at it, you have Na, O, I just draw the structure of Na2, so it is like ONA and ONA on either side of sulfur. So you have NaO, S, S, S and S. 4 S are there in a line like this, plus and you have then ONA here, and you have O here, O here, O, and yes, O here. Do you get that? By chance in this particular case, the one that you are finding out from the structure as well as from the normal way that you've learnt is coming out to be the same. But otherwise there is another way of doing it. The oxidation state of sulfur with coordinate bonds, the oxidation state, this you can note down. The oxidation state of sulfur, it has two coordinate bonds. So when it has both the coordinate bonds, because sulfur belongs to your oxygen group, so that means normally if it has two single bonds on either side, it will have two lone pair of electrons. Two lone pair का मतलब है कि it can form two coordinate bonds. You remember पुराना concept of chemistry that you've done? NH3 is normally this, N is sp3 hybridized. You may have to find out, I am taking it for granted that you know now NH3, in NH3 N is sp3 hybridized. Because of this lone pair, it can extend its covalency to another atom and form NH4 plus. वो कैसे होता है? It actually forms a coordinate covalent bond with a hydrogen and gains a positive charge. So it forms NH4 plus. Clear to everyone? Similarly, sulfur has two lone pair of electrons, so it can form two coordinate covalent bonds. The oxidation state of sulfur here will be plus 5. ठीक है, ये तो elemental state में हो गया, इधर भी ऐसे, इधर भी ऐसे. It's some kind of an elemental state of sulfur where it's showing the catenation tendency. So in this case it will be the oxidation of sulfur having the SS bond will be 0. Note it down. The oxidation state of sulfur showing coordinate covalent bonds is plus 5, and the oxidation state of the sulfur in the SS bond, it will be 0. So if this is the case, then look here, this is plus 5, this will be 0, this will be 0, and this will be again plus 5. So it will be plus 5. So total of all the oxidation numbers divided by the total number of atoms. कितने सल्फर हैं? 4. पर पहले plus 5 plus 0 plus 0 plus 5 divided by 4. So it is again 10 by 4, which is 5 by 2. Clear? Now for CrO5, what is the oxidation state? No, now that's wrong because you needed the structure. Remember for CrO5, it's again the structure. Now I'll give you the structure, it's not plus 10. How did you find out plus 10? X minus 10 is equal to 0. So you found it to be plus 10. So now I'm giving you the structure, carefully look at it. Cr, O, O, alright. Remember the O2 linkage in any molecule is your peroxide linkage. ठीक है, H2O2 is your peroxide linkage. So here we have CrO here, okay, and you have the normal O here. So the oxidation state of this O is -2, this is -1, -1, -1 and -1. Okay, remember, draw the structure of CrO5 first. All of you all draw the structure of CrO5. Remember that this is a peroxide linkage because you have an OO linkage directly here. What is your peroxide linkage? Wherever you have an OO kind of a linkage, H2O2, Na2O2, all these are your peroxide linkage. Where you have a superoxide like KO2, there your K is attached to O on one side and O on the other side. There is no connection between the two O. एक O इधर है, एक O इधर है, but those two O's are not attached. When those two O are attached in the molecules, it's a peroxide linkage and the O will now have an oxidation number of -1. And when O is just like that, like H2O or some other kind of form where it's like freely lying, so it will have a normal oxidation number of -2. तो अब इस केस में क्या हो गया? You will have -4 or 4 into -1, that's -4. Then you have -2 plus x, the way you want to do it now, or that is equal to 0, right? So in this case, x can be put to be equal to, please explain Na2S4O6 again. Na2S4O6, let me just complete this first, I'll just come to it again. What you have in CrO4O5 now, you have -4, -2 plus x is equal to 0, so x will be equal to +6. X will be equal to, x will be equal to +6. That again depends on how the elements are linked to one another. If they're continuously linked to one another, then in that case that is possible, and if they're not linked to one another, then this is the best method. Okay, for explanation of Na2S4O6, you can follow the normal protocol also. The normal protocol was giving you +2 plus 4x, this was it, right? +2, because Na is +1, so it is +2, and S is what we are finding out, so that becomes +4x minus 6 into 2, that is, or 6 into -2, that's -12, so that's equal to 0, and so x becomes equal to simply 10 by 4, which is 5 by 2, and I gave you the molecule simply because so that you know, here what you have is, that was NaO, S, 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 ONA, this was your Na2O2S4, but you have how many O? 4. No, 6. So you have 4 more forming a coordinate covalent bond with 2 sulfurs which are there at the either end. So the structure of Na2S4O6 is important so that even if you look at the structure, you do not get confused. So here you have a +5 for the sulfurs which are there at the either end. +5, I'll come to H2SO5 also. That's, sorry, I just missed it. So I'll just come to it. H2SO5, okay, next, yeah, coming to it. Then here, because that was a doubt before, to explain Na2S4O6, तो इस केस में हमने क्या किया था? We added up the ones which are in the surrounded by in the SS state, elemental state, they are like 0 and 0. So what we did in this case, we added up all, and then we divided it by, then we divided by the total number of atoms, and so we got the same, right? Then now let's come on to H2SO5. Now I'll tell you again. You understood CrO5? I came up to CrO5 before H2SO5. I'm really sorry for that. So I'm coming back to H2SO5. Okay, now I'm talking about H2SO5. Gonna give you the structure. Please explain CrO5 again. CrO5 again. Okay. Cr, O, 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 O. So here Remember that whenever you have the oxygen in the peroxide linkage, it will always be -1, -1, -1, -1. This will be -2. So you have -1, -1, -1, -1, -4, -2, -6 plus x is equal to 0. So x is equal to +6. Now for H2SO5, I'll unfold the mystery by giving you the structure. Check out the structure, draw it and get me the correct answer now. HOS, you have to find it out for S, let me tell you. And for, I suggest, rather than getting confused, take Na2S4O6 by the normal methodology. Because they are in continuation, I repeat, Na2S4O6, rather than going into the complications of the structure, calculated by the normal route. That is +2 plus x minus 12 is equal to 0. That was it. So calculated by the normal way. Here, because you are finding out for sulfur, you can straight away have the tendency to say it will be this. So do not say that. O, alright, then you have O, O and H. Now apply your common sense. Please apply your common sense. You have to find out the oxidation number of S, this S. Remember there is an O linkage, that's the hint. This O is free, this O is free, this O is free. That is not a superoxide linkage, that is no other linkage, that is a normal oxygen. So now tell me what will be the oxidation number of sulfur? What will be the oxidation number of sulfur? Yeah. See, this is a peroxide linkage, OO. So what will be the oxidation number? -1, -1. What will be this? -2, -2, -2. And what about this one? +1. Okay. So add all of them plus x is equal to 0. So alright, -6 तो ये 3 का हो गया oxygen, -2 plus 2 plus x is equal to 0. So x is equal to +6. So done with H2SO5. I'm sorry, I just missed it. Okay, now for done with all. Is there any difference between the peroxide linkage and peroxy linkage? See, normally the peroxide linkage is what we are talking about in the OO group. When you talk about the peroxy linkages, there is a separate branch of chemistry that you can talk about also. Similar to this, but that's like peroxide linkages can be linked to your peroxy linkages, but here we're just laying emphasis on the OOO bonds that can be taken as taken up as your -1 oxidation state. We're just finding out the oxidation number, the simplest of all the things that you can do in chemistry. Alright, next, NH4NO3. It's a salt. Both these nitrogens are different from each other. So plus 2x nahi le sakte. You cannot take plus 2x in this case because this nitrogen is different than this nitrogen. Why? Because this is a salt. ठीक है? इस case में this is forming NH4 plus and this is forming your NO3 minus. So we can find it out separately. NH4 plus and NO3 minus. Find it out and tell me. What did you work it out otherwise? पहले भी तो किया था पहले. So that is going to give you a wrong thing. So remember that by just looking at the molecule, you have to think about it as to how to predict the oxidation number. So इस case में एक particular oxidation number देना will be wrong. -3 and +5. Correct? Then once you know the basic funda, then you can easily find it out. Why? Because if this nitrogen is X, X plus 4 is equal to +1 because that's the charge on the molecule or sorry the ion. So then in that case X will be equal to -3. So this nitrogen is -3. ठीक है? Or next in NO3 minus it is X minus 6 is equal to -1. So X is equal to +5. So this nitrogen will be symbolized as +5. Then I gave you randomly another problem that was manganese and MnO2 and Cr in CrO3. That's simple. Manganese is in +4 oxidation state. इससे ज़्यादा simple तो हो नहीं सकता problem. X minus 4 is equal to 0. So x is equal to +4. And the next case we have x minus 6 is equal to 0. So x is equal to +6. Finished? These set of problems. What should I do by the normal rule? Please specify. H2SO5 by the normal rule. If I do it by the normal rule, it may turn out to be wrong, because if you check out what was it by the normal way that you had calculated, check it and tell me. It turns out to be 8, but otherwise what did we find it out to be? It's +6. So if you do it by the normal rule, it will turn out to be wrong. ठीक है? और अगर आप if this question has come up from the same center which was asking for Na2, what was that? S4O6. इसको normal rule से करोगे तो ये ठीक आएगा, because this will be Na is always in +1 oxidation state, group 1. So +2 plus 4x minus 12 is equal to 0. This is what it was. And then you had 4x is equal to plus 10 and x is equal to, right? I don't know which problem you were asking about, but for certain cases remember that when the structure has different kinds of an atom, different kind of atoms attached to it, you have to look at it from a different perspective depending upon which type of oxygen. That is why you did the rules. Okay, now how will we know in which question we have to take the structure and which by formula? Alright, that's a very good question. In normally majority of the cases wherever you have bridged atoms कौन से होते हैं जो इधर भी कुछ है इधर भी कुछ है, तो normally when you have the structure in which you have bridged atoms, you generally look at the structure and then decide. Na2S4O6, by chance I took up a complicated problem right at the first go. So in that there are two ways of looking at it, one by the structure and other by the normal method. When you do it by the normal method, उसमें ठीक आ रहा है, तो let it be. Now when you talk about CrO5, you saw that in that there was a peroxide linkage and there was a normal oxygen that was there as -2. तो उस case में structure becomes important, because your oxidation state is then decided by the structure itself, as was in case of H2SO5, which somebody very intelligently reminded me that I missed out, and thank you for that. Okay, so in many cases you need to, and how will you know about it? There are certain set of examples that probably are like asked and repeated in the examination that you can go through, or else ideally speaking I believe that the structure should be given in the examination, because you are not expected to remember a lot in sciences. I mean, you should have your concepts clear but not remember a lot. So there can be either the structure given, or in some of the acids, let me tell you, in 12th standard you will be doing the structures of these acids also. So then it will become a cakewalk for you. All these structures of acids will have to be done in S and P block chemistry. So then you won't be asking that question whether the structure should be given or not. So structures can be known slowly, steadily by practice. Okay. Now there is something which is known as stock notation. Stock notation, that's like just the way of giving up a representation to your oxidation number. That's a way of giving a representation to your oxidation number. Like for example, if you have, see, there are certain elements which exhibit variable oxidation states. Variable oxidation states, like in CrO3, what was the oxidation state? You told me it was +6. In K2, did I give you this example? K2Cr2O7, what was the oxidation state in this? It was again +6, alright. Then okay, then your Cr can also exist in +3 oxidation state also. Okay, so there are many cases in which your element in itself displays variable oxidation state. Like you talk about oxygen itself. Oxygen के आप कौन-कौन से oxidation numbers कर लिए? You've done -half, you've done -1, -2, +2, +1. So you have done variable oxidation states. So here the oxidation state of certain elements which exhibit variable oxidation states can be notified with the help of stock notations, which are talked of almost in all the books. So I thought I'll just tell you this thing also in stock notation. Like for example, in this, the oxidation number is expressed in Roman numerals in brackets. It's simply that. The oxidation number of your element is expressed in Roman numerals in brackets within parentheses is how it's said, or the name after the symbol or the name of the element. Like for example, if I say Cu2O, okay, find out the oxidation state of copper. It will be, it is cuprous oxide. It is cuprous oxide. So it can either be written as copper, that's the name. See, the general name of the molecule is cuprous oxide. But if I have to write down the stock notation for it, it is the name or the symbol followed by its oxidation number in brackets. So it will be copper. What is the oxidation number? Plus 1. So copper 1, and then you write oxide. Okay? Or you write it as Cu2 1O. The O is sticking to almost this. So it's O. Alright? So there's no space between the bracket and your O. Okay, next you write this down quickly. Fe2O3, it's like ferric oxide. So what will that be? That will be, find out the oxidation state of Fe. It is 3. So how will you write down the stock notation? Fe2, 3 in brackets, and then you have O3 or in words? No. You don't know the name of Fe, that's iron, and you write it as 3 space and oxide. Clear with it? It's not a Herculean task to understand this, it's very simple. Okay, HgCl2, commonly known as mercuric chloride. That's the common chemical name, mercuric chloride. Mercuric chloride. Now, so this will be, find out, Hg is simply 2. Hg 2. This is like the oxidation number in parenthesis. So how will you write it down? Mercury 2 chloride. Mercury 2 chloride. Done with the stock notations? 2 more examples as I rub the board and you utilize your time. Find out the oxidation state of sulfur in SO4 2 minus and SO3 2 minus. Okay? Find it out. Oxidation number. Oxidation number is generally the oxidation state also, because the oxidation state is generally signified by the oxidation number only. 4 and 6. So again variable oxidation state. So you getting the point? So it will be 4 plus 4 here for sulfur and plus 6 here. Okay? Normally I am just telling you as a trend. Understand, the one which has a lower oxidation state, ठीक है, किसी का मान लो oxidation state is +1, and you know it is capable of showing variable oxidation state. So +1 is a छोटा value, so it can get increased. That means that compound will have the property of oxidizing itself. Like for example, I am just deviating from the topic because I'll come back to it again, because now you've done oxidation numbers. सबको निकालना आ गया, इसमें तो कुछ करना ही नहीं है. So now if I talk about a molecule, you know this is an oxidizing agent. ये से पढ़ा है, बहुत पढ़ा है. Alright, this is an oxidizing agent. So why is this an oxidizing agent? Because like you have an insurance agent. The insurance agent, if he comes here, what is he going to do? He is going to do insurance for all of you all. अपनी थोड़ी करने बैठेगा. You getting the point? So a person who will be doing something for you. So similarly, this is an oxidizing agent. So what will it do? It will oxidize the other molecules with which it will react. Getting the point? So oxidizing agent is the one which will oxidize the other molecule, but in itself will reduce. समझ में आया? At the cost of itself, it will oxidize the other molecule. So here, like if we have KMnO4, इसमें oxidation state you just found to be +7, +1, -8, so +7. ठीक है? So the oxidation state of manganese is +7 here. Now if it is +7, I know manganese can exist in +4 also, like MnO2 था. ठीक है? तो this is one of the highest oxidation state. तो अब ये इससे ऊपर तो जाएगा नहीं. +7, +8 is the highest oxidation number which is shown by osmium. Getting the point? I'm just telling you, you've done periodic table. We've done some sets of oxidation states there also. That was defined by the valencies commonly. So now here, if an element has one of the highest oxidation states, it cannot increase further. It will only have the tendency to reduce. तो ये खुद reduce होके it can oxidize the other molecule. So whenever you have an element in its highest oxidation state, you can say it can act as an oxidizing agent. And whenever any molecule is in a low oxidation state, then low से वो high अपने आप को कर सकता है. That means जो खुद oxidize होगा वो दूसरे को reduce करेगा. So if you get this point for temporarily, let it go into your mind, slowly and steadily get filtered. And in the meantime, let's talk about the basic thing that we are doing today. We are doing now, coming back to the same thing, because this in itself contains your topic. Redox reactions. What are redox reactions? These are the chemical reactions in which oxidation and reduction are happening simultaneously. In one reaction, you have the oxidation also happening and reduction also happening. What are redox reactions? जिसमें कोई compound definitely is getting oxidized and some other element is definitely getting reduced. So that is your redox reaction. So that is, and remember that all redox reactions are accompanied by some change in energy. That can be in the form of heat, light, electrical, whatever energy. All these redox reactions are accompanied with change in energy. Anything that is happening in nature, even if you moving your hands like this or wherever, you are actually involving change in energy. Okay, so so let's talk about the different types of redox reactions now. Different types of redox reactions can be, one can be intermolecular redox reactions. Intermolecular redox reactions. In intermolecular redox reactions, what happens in this case, oxidation and reduction is taking place in between separately in two compounds, like SnCl2 plus FeCl3 is giving SnCl4 plus FeCl2. I'll balance it for you. Okay. SnCl2 plus, in this what is happening, two compounds are separately getting oxidized and reduced. Write down the oxidation number of each and every element. I know it's a post-lunch session, so you need to be active throughout. So what will happen in this case? Quickly write down the oxidation number for each one, and you will find out that one of them is getting oxidized and the other is getting reduced. What is Sn in SnCl2? +2. And what about here? +4. So that means Sn is getting oxidized. So एक अपना separately oxidized हो गया. Now let's look at Fe. Fe was +3 initially and now it has become +2. So क्या हो गया ये? Reduced. So Fe got reduced and Sn got oxidized. So this is intermolecular. Intermolecular means two compounds separately got oxidized and reduced. So you had oxidation of tin and reduction of iron. Just one or two more examples for this. No, let's move ahead. Simple. Any problems in understanding this from anywhere? No. Then we have intramolecular. Very good. So in this case, what happens in these, oxidation and reduction is taking place in a single molecule, not separately but in a single. Like for example, these are also different classes of reactions that I will talk about, and you've done it also. You have like KClO3. Okay, KClO3 gets split into KCl and O2, right? This is a reaction in which इसको हम disproportionation reaction भी बोलते हैं. I will talk about it again, but if you get it, fine. Otherwise, I'll repeat it. Intramolecular redox reaction is the one in which you have one compound और उसी में से एक element oxidize हो रहा है और वही element reduce हो रहा है. How do we look at it? Some other element, in which you are talking about two elements. One of the elements is getting oxidized and the other is getting reduced. Like for example, in this, look at Cl. Cl here, what is the oxidation state of Cl? Find it out. It will be +1 plus x minus 6 is equal to 0. So +5. वर्कआउट करके तो नहीं दिखाना? सबने कर लिया? Yes, बोलो. So what you have is KClO3. So here Cl will show an oxidation state of +5. Now here it becomes. So what is happening to Cl? It is getting reduced. Oxygen here was -2, क्योंकि हमने KClO3 में उसको -2 लिया. इधर क्या हो गया oxygen? Oxygen turns out to be 0. So in this case, -2 से 0, it means it got oxidized. बढ़ गया ना, -2 से 0 हो गया. So your oxygen is getting oxidized and Cl is getting reduced. So this is intramolecular redox reaction in which two elements of the same compound are getting oxidized and reduced at the same go. Clear with the intramolecular redox reaction? Now I was talking about, disproportionation reaction. Let me just talk about it now. In disproportionation reaction, you have like Cl2 plus OH minus is giving you ClO minus plus Cl minus, ठीक है, plus H2O. This is what I call as the disproportionation reaction. Disproportionation reaction. These reactions involve reduction and oxidation of the same element of the compound. मैंने पहले disproportionation समझाया, but I changed it for this because in this case different elements are getting reduced and oxidized. In this case, same element is getting reduced in one case and the same element is getting oxidized in the same reaction. So here what is your Cl? 0 है यहाँ पे, ठीक है, Cl 0 है. यहाँ क्या हो गया? It is, find out the oxidation state of Cl in all these cases. It is -1 क्योंकि Cl minus है तो oxidation state is clearly -1. इधर क्या है? X minus 2 is equal to -1, so it is +1. Are you all here with me? Yes, +1. So what is happening from 0 to 1? It is getting oxidized, and here chlorine is also getting reduced from 0 to -1. So such reactions in which the same element is getting oxidized and reduced are known as disproportionation reactions. No. Intra is one element. Okay. Now we are talking about different types of redox reactions. You all now know how to find out the oxidation number. Now when you talk about different types of redox reactions, in redox reactions what you have is, you have intermolecular redox reactions. उसमें क्या होता है? You have two compounds and दोनों compounds का एक element is separately getting oxidized and reduced. जैसे you have two compounds here, SnCl2 reacting with FeCl3. So your SnCl2 में Sn is getting converted from +2 oxidation state to +4 oxidation state because SnCl4 is getting formed. So this is like and FeCl3 is forming FeCl2. So here +3 is getting converted to +2 for iron. ठीक है? So here what we see is that tin is getting oxidized and iron is getting reduced. So intermolecular redox reactions are the ones in which two elements of two different compounds are getting oxidized and reduced simultaneously. So in your NCERT you have many questions. You are given a reaction and then you are asked to find out justify that this is a redox reaction. उसमें justify में आपको क्या करना है, सिर्फ आपको ये बताना है कि किसी की oxidation हो रही है और किसी की reduction हो रही है. Because in one particular reaction if you are able to prove that oxidation and reduction is happening simultaneously, then you say it's a redox reaction. Then we talk about intramolecular redox reaction. In intramolecular redox reaction you have only one element or one compound and elements of that compound are only getting reduced and oxidized simultaneously. Like for example in KClO3, I have noted down the reaction. KClO3 is forming 2 KCl plus 3O2. ठीक है, oxidation number find out कर लो हर एक element का. This will be +1, this will be +5, this will be -2. So +5 will automatically come because O has to be taken as -2 from the set of rules of oxidation number. Here Cl will be -1, K will be +1. Here oxygen will be 0. So we see that Cl is getting reduced from +5 to -1 and oxygen is getting oxidized from -2 to 0. -2 to 0. So बढ़ रहा है इसका oxidation number, so this is getting oxidized. So again reduction and oxidation happening simultaneously from the same molecule, तो intramolecular redox reaction. Now for disproportionation reaction, that is that kind of a reaction in which one element, disproportionation can be intra also and it can be inter also, let me tell you. ठीक है, लेकिन disproportionation का एक characteristic feature ये होता है कि एक ही element उसी reaction में oxidize हो रहा है और वही element is getting reduced. Like in this particular case, Cl is the one which is getting oxidized to +1 state in ClO minus and Cl in itself is getting reduced from 0 to -1 state in this reaction. So that is why where the same element is getting oxidized and reduced at the same go, then that reaction is known as disproportionation reaction. Yeah, then we can have other examples also. Clear with this? Okay, now another classification of your, what is this? Redox reactions. So you have direct redox reaction. Then you can have, अगर direct है तो next will be indirect redox reaction. Now when I talk about direct redox reaction, it is the chemical reaction in which oxidation as well as oxidation and reduction is carried out in the same container. Is carried out in the same container. Now you must be wondering which container, why to take containers, why to talk about containers. These oxidation and reduction reactions are used to create cells. Physics mein, I don't know if you started doing Daniell cell, Leclanche cells. No, then you will do it in chemistry also and physics also. Wait for some time. So here these are used for preparing cells. Now sometimes in a cell you make the reduction and oxidation reaction happen in just one chamber. Okay, एक ही chamber लिया. We'll be talking about cells also briefly as we proceed on in our course of redox reactions. एक हमने container लिया, उसी में हमने दोनों reactions करवा दिए, reduction भी, oxidation भी. So then it will be called what? It will be called as a direct redox reaction. But I can also do one thing कि एक container में I can actually carry out reduction and in another container I carry out oxidation but then oxidation अलग हो गया, reduction अलग हो गया, तो then I will have to connect it using a salt bridge. ये word अभी याद होता है तो ठीक है, नहीं होता तो भी ठीक है. You just have to connect the two. तब पूरा cell बन जाएगा. You have a oxidation chamber and you have a reduction chamber. When they are carried out in two different containers, then you call it. So oxidation reduction in same container in separate containers. Separate containers means oxidation in one and reduction in the other, and they need to be connected to form a complete set of KCl. And a reaction in which oxidation and let me tell you, in such reactions generally when they are taken in the same container, the energy generally liberated is in the form of heat energy. And in this case generally the energy which is liberated is in the form of electrical energy. Just a general demarcation. कुछ समझ में आया? We can take up the examples as we talk about cells also. I repeat, direct redox reactions are the chemical reactions in which oxidation and reduction is carried out simultaneously in the same container. That is known as direct reactions. In this case, the energy liberated is generally the heat energy. Indirect redox reactions are the ones in which your oxidation and reduction are carried out in separate containers, and the energy which is generally liberated is your. Okay, now let's talk about the oxidation and reduction one last time. See, now you can easily state you have Mg plus O2, just to take up more examples and make it look simpler for you. So write down the oxidation numbers of each of the elements. Alright, so and suggest now according to the oxidation numbers whether it is getting oxidized or reduced. So you just have to tell me whether it's an oxidation reaction or a reduction reaction. So you have H2S plus O2 giving H2O plus S plus 2S, alright. H2S plus Cl2 is giving 2HCl plus S. Shh, quiet. Alright, written oxidation numbers for each, very good. All of you all need to be as quick as now this is like 0, 0, 0, no, plus 1, minus 2, alright, plus 1, minus 2, 0. So sulfur is going from minus 2 to 0, means what is happening? Oxidation. Sulfur is getting oxidized, means what is happening? Oxidation. ठीक है? ये तो जल्दी जल्दी साथ के साथ लिखते जाओ. If you're doing redox means you have to write down the oxidation states. Or in this case what is happening? Mg becomes plus 2 minus 2. So your Mg is getting oxidized and oxygen is getting reduced. Or else when you look at it from your previous simple concept, oxygen is getting added. So what is happening? Oxidation. Oxygen add हो रहा है मतलब oxidation. So this is a type of, which type of a reaction? Oxidation reaction. Either this is plus 1, this is minus 2, this is 0, this is plus 1, this is minus 1, this is 0. So sulfur is going from minus 2 to 0 means sulfur is getting oxidized. Your H is going from plus 1 to plus 1, so nothing is happening to H. H as it is has to be taken as plus 1 only. And then you have Cl. Cl is going from 0 to minus 1. So Cl is getting reduced. Now for Fe2O3 also work it out. Now tell me quickly for this, what is Fe in Fe2O3? Plus 3, 2x minus 6, so it will be 3, and then this will be, oxygen will be minus 2, carbon will be plus 2 here, minus 2, I can take it to be like that. Let's talk about iron. What is happening to iron? It is going from plus 3 to 0, so iron is getting reduced. Huh? Oxygen is like minus 2 and minus 2 throughout. I heard somebody saying oxygen is getting oxidized. That's like the statement of the day. So you cannot talk about oxygen like that. so it will feel bad. So you have carbon going from a +2 to a +4 state, so you can say that, that's good. But your main focus is on the metal or iron that we are talking about, so that goes from +3 to 0. So that's getting reduced. इसको तो देखते ही बता दो what is happening here. Very bad. Loss of electrons. Oxidation. This is like whenever you're losing electrons, it's always oxidation. Is basic topic mein to there should be no mistakes at all. You have loss of electrons means it's oxidation. Electrons on the right always means it's oxidation. And whenever you have gain of electrons, it's always reduction. Now let's talk about reductants and oxidants. This is what I was trying to explain just now, just a few minutes ago. Oxidants and reductants. We still have time, so we can easily discuss them. See, reductants are the ones which are also known as your reducing agent. So it's an agent. So reducing agent है तो ये दूसरों को क्या करेगा? Reduce. और खुद को क्या करेगा? Oxidize. A reducing agent is that chemical substance which can accept or one or more electrons and causes the, एक minute, what am I talking about? A reducing agent is the one which can generally lose electrons and oxidize other species. Lose electrons and let me tell you, for oxidants, let's talk about the oxidizing agents also. Oxidants are oxidizing agents. And what are oxidizing agents? Which will oxidize other molecules or other elements by reducing themselves. Right, reducing themselves means, I'll just give you examples. Find out, say K2Cr2O7. Okay? Find out the oxidation state of elements which are in their highest oxidation state. Generally, those compounds in which the elements are in their highest oxidation states, they act as an oxidizing agent. क्योंकि उस oxidation number से ऊपर वो जा नहीं सकते. So there is only one option, that they will reduce themselves and oxidize others by doing so. So in this case, what is the oxidation number of Cr? You've already done it once, +6. So it's already very high. So from +6 it can go to +3 or some other oxidation state and reduce itself. So this is an oxidizing agent. Okay, talk about KMnO4. This is also an oxidizing agent. HClO4, this is also an oxidizing agent. Note down these names of examples of oxidizing agent: H2SO4, KClO3, and cerium sulfate can also be used as an oxidizing agent. Cerium sulfate can also be used as an oxidizing agent. SO4 is 2 minus, so 2 minus means 2 minus into 2. Sulfate is -2, directly ले लो, sulfate is SO4 2 minus. So 2 minus into 2 will be -4. So X minus 4 is equal to 0. So cerium will be in what state? +4. Cerium will be in +4 oxidation state. So from +4 it can go to +2. And there are some more oxidizing agents that you can talk about, that are the oxides of metals and non-metals, like MgO. All these can also be used as an oxidizing agents. CrO3, CO2, etc. ये non-metal हो गया, ये metal हो गया, CrO3. So now what you have is, you can also have important oxidants. Molecules of most electronegative elements like O2, O3, etc. are the ones which can be used as oxidizing agents, because they have to supply oxygen. So the definition of oxidizing agent will be the one which can accept electrons. So note down the characteristics of oxidizing agents. They will accept electrons, they will oxidize the other species, they can accept electrons and hence reduce themselves. खुद reduce होंगे, दूसरे को oxidize करेंगे. We'll look at the reactions to have a better understanding also for the same. Then for reducing agents, now write down for the reducing agent similarly. What will be reducing agents? Which can lose electrons and hence themselves get oxidized and reduce other species. And they can reduce other species. Okay, same case. You can have metallic hydrides as the reducing agents. What are your metallic hydrides like? NaH, then you can have LiH, KH, CaH2. All these are metallic hydrides. They can be used as reductants. Now, why reductants? Look at the oxidation state. Now, Na is in +1 oxidation state, hydrogen is in? So, where is the catch? Na तो +1 से कहीं जाएगा नहीं. Na तो 3s1 है, वो 3s1 ही रहेगा. So, it can just give 1 electron. So, it will always remain as +1. So, किस में change आ सकता है? Hydrogen. Because hydrogen can go from -1 to 0 to +1 also. Right? So, in this case, you know that hydrogen has a tendency कि वो अपने आप को oxidize करके दूसरे को reduce कर दे. तो hence it is a reducing agent. Now, so is the case in other hydrides. Because your metals will remain in the same oxidation state. समझ में आ रहा है? पर hydrogen अपनी lowest oxidation state which is possible में है. It is hydrogen is in the lowest oxidation state which is -1. And if it becomes H2, then it goes from -1 to 0. So it is getting oxidized. Hydrogen is getting oxidized. So जो दूसरा element होगा that will get reduced. Like for example, let me just take, जैसे अगर NaH लिया, ठीक है, NaH plus, alright, NaH is forming your Na plus half H2, ठीक है. So Na was in +1 -1 state hydrogen. So Na becomes now 0 and this becomes 0. Yeah, 0 and 0. So Na is now getting reduced and hydrogen is getting oxidized. So this is like one example where hydrogen actually now has a tendency that it can move to a higher oxidation state while reducing the other species. Okay, more examples of this. All metals and some non-metals can also act as a reducing agent. Now, the compounds having an element in its lowest oxidation state can actually be used as a reducing agent then. And there are some which can act both as an oxidant as well as reductant. Reducing agent के और examples लिख लो. The compounds which are having which generally exist in the lowest oxidation state, and find out the oxidation state also. H2C2O4. This is your oxalic acid. COOH, COOH. The structure is this. No need, which you can easily find out. 4C2H2. So this is your oxalic acid. This can act as a reducing agent. Then you can have others like FeSO4. Either Fe is in which oxidation state? Fe is in which oxidation state? SO4 is what? -2. यहाँ पे सल्फर की नहीं पूछ रही मैं, because सल्फर की फिर निकालनी पड़ेगी. सल्फर also can have. So SO4 is 2 minus. It's an anion. वो 10th standard में you had a table. Do you remember that you were supposed to remember for the anions? It's always beneficial to do it. So here, so you have, और मैंने अभी बोला NH4 NO3 में भी you separated out your NH4 plus and you segregated your NO3 minus. So here also your Fe and SO4 needs to be separated out. So you have Fe 2 plus and SO4 2 minus. तो इस केस में again Fe अगर +2 में है तो इसका मतलब Fe exists in +2 and +3 oxidation state. So and it also exists in 0 oxidation state in the normal Fe form. So in this case, why will it act as a reducing agent? Because Fe can easily get converted from +2 to +3. So अगर ये खुद oxidize होगा तो दूसरे को क्या कर सकता है? Reduce. So it can also act as a reducing agent. All these things just need to be understood like that. Like H2S है, तो H2S में H तो definitely is +1. Your sulfur is in -2 oxidation state. So it can increase its oxidation number while reduce the other species. Then you can have SO2 also. SO2 because sulfur can exist in +6 also, and we've seen other examples also of higher oxidation states of sulfur. Here it is in -4. Oh, sorry, +4. It is x minus 4 is equal to 0. So sulfur is in +4 oxidation state, so it can actually go to higher oxidation state also. Now, okay, let me just tell, okay, this is also a good reducing agent, which is Na2S2O3. Find out the oxidation state of sulfur. Na will definitely remain in 1 क्योंकि हमने वो rules में करा है, group 1. So it will be +2 plus 2x minus 6 is equal to 0. So 2x will be equal to -6 plus 2 is 4. So it is like +4. So x is equal to +2. So +2. Sulfur is in +2 oxidation state. So this is known as a hypo solution. Na2S2O3 is also known as a hypo solution. Okay. Now some compounds which can act both as an oxidant as well as a reductant are SO2, क्योंकि SO2 +4 में है. Now you've seen S can also exist in +2, 0. It can also go to +6, right? So in that case, you know that it can either act as a reducing agent as well as an oxidizing agent. Okay, another example is HNO2. Nitrogen ka to, when we, I think we've done it, when we were talking about the p block chemistry, nitrogen exists in -3, -2, -1, 0, 1, 2, 3, 4, 5. These are the different oxidation states which are possible for nitrogen. So in that case, like if HNO2 is there, find out the oxidation state of nitrogen here. It will be +1 plus x minus 4 minus, answer is +3. So from +3 it can either go to a lower oxidation state or it can go to a higher oxidation state. So it can act both as an oxidant as well as a reducing agent, reductant. Okay, another one is H2O2 similarly. These can act both as an oxidizing agent as well as a reducing agent. So you just have to apply your mind. If your element is in its highest oxidation state, so then it can only act as an oxidizing agent. क्योंकि जिसका oxidation number already बहुत ज़्यादा है, वो अपने आप को क्या कर सकता है सिर्फ? Reduce while oxidizing the other species. So if the oxidation number of your element is high, then it will always act as an oxidizing agent. And if the oxidation number is low, then it will act as a reducing agent, क्योंकि then in that case it can oxidize itself while reducing the other species with which it is reacting. And oxidant and reductant कौन act कर सकते हैं? जिनके पास ऊपर नीचे जाने का दोनों का option है in terms of oxidation number. The one which can either gain electrons or lose electrons. So that is another important aspect. Now how do you find out the equivalent weight? This is also an important question. How to find out the equivalent weight of the oxidant or reductant? How to find out the equivalent weight of the oxidant or reductant? See, it is generally the equivalent weight, you can just write down, the equivalent weight of oxidant or reductant. The equivalent weight of the oxidant or reductant is equal to molar mass divided by the change in oxidation number. Change in oxidation number. Now, the change in oxidation number मतलब जो reaction से पहले था and बाद में था, you have to take the difference of the two. So, let's find it out by understand this with the help of an example. Let's take up a disproportionation reaction. What is a disproportionation reaction, by the way? In which one particular element in itself is getting oxidized as well as reduced. एक ही element. So that is a disproportionation reaction. So you take up an example of H3PO3 in which it is getting converted to H3PO4 plus PH3. So write down the oxidation state. Write down the oxidation state of Alright, there's a question, why is H2O2 also as an oxidant as well as a reductant? In H2O2, what is the oxidation state of hydrogen? It is plus, this is the question which has been asked, it is +1 only. And what is the oxidation state of your oxygen? It is plus 2 plus 2x is equal to 0. Plus 2x. So then your 2x becomes equal to minus 2 and x becomes equal to minus 1. Now when your oxygen is in minus 1 oxidation state, you know that this minus 1 can also exist in 0 oxidation state, or it can go lower to minus 2 oxidation state. ये H2O2 0 कब होगा? When this will just form O2. ठीक है? So if oxygen can go, so then that means H2O2 in itself can get oxidized while reduce the others. So then it can act as a reducing agent, and when it itself can get reduced from minus 1 to minus 2 state, जब वो खुद reduce हो जाएगा minus 1 से minus 2 state में, तो उस केस में वो बाकियों को क्या करेगा? Oxidize. So that is why when your H2O2, the oxygen in H2O2 can get oxidized as well as reduced, and therefore it can act as a reductant as well as an oxidant. सिर्फ ये चीज याद रखना कि reducing agent will itself get oxidized and reduce other species. An oxidizing agent itself will get reduced and oxidize other species. वो अपना काम सिर्फ दूसरों पे implement करेगा. So oxidizing agent will oxidize others and reduce itself. So एक याद रखोगे तो second one will automatically be remembered. So that is the funda of oxidation. And the species which can act both as well as an oxidant as well as reductant will be the one which is in some intermediate oxidation state, जिसके पास chances हैं to increase its oxidation number or to decrease its oxidation number. Yeah. Okay. So now coming back to this question. Don't remember. So here, no, I'll just explain how to solve it. So in this case, H3PO3, in this, what is the oxidation number of phosphorus? Here what you have is oxidation state, plus 3 plus x minus 6 is equal to 0. So x will be equal to, so plus 3 here, right? And then let's talk about here. So here it will be plus 5 and this will be minus 3. ठीक है? ये कर लिया सबने? Now how to find out the equivalent weight is a question. The equivalent weight will be, so that means we are finding out the equivalent weight of H3PO3. That will be the molar mass of H3PO3, provided you know the mass of H, P and O. That will be the molar mass. Now it is undergoing two types of reaction divided by the change in oxidation number. अब change in oxidation number दो type के हैं. एक, there is like a change of plus 2 and the other is a change of minus 6, right? So there is a change of plus 2 from plus 3 to plus 5 and there is a change from plus 3 to minus 3, which is like a change by an oxidation number of 6. So it will be m by 2 plus m by 6. This will be the equivalent weight of, so that becomes equal to, you can easily solve it, 6 will be the LCM, so it will be 2m plus, no, in this case you will be talking about the change, the magnitude of the change in the oxidation number. So we will be talking only about the magnitude of the change in the oxidation number, and the change in the oxidation number is just plus 2 and 6. So I mean the magnitude is like 2 and 6. So here it is m by 2 plus m by 6, it will be like 2m plus m, 3m. So it will be 4m by, no. This will be 3m plus m, yeah, 4m by 6. So that will be equal to 2m by 3. This question has been put up once. So you should be able to find out the equivalent weight. Now it depends as to how many times it is getting changed. मान लो the phosphorus was like only in one of the compounds, then it would have been simply m divided by the change in the oxidation number of that. I took up this example especially because in this phosphorus is showing two oxidation states. So दोनों को हम consider करेंगे and then we'll add it up to get the total equivalent weight. Okay. So let's talk about other different types of reactions which are possible. The other different types of reactions are like you can have combination reactions. Types of redox reactions main, this is what you've done before. What have we done? We have done what types of redox reactions? One was depending upon whether you have two molecules combining or one molecule only. One was intermolecular. In intermolecular, two elements from two different compounds are getting oxidized and reduced. In intramolecular, two elements from a single compound, like KClO3 में Cl and O were undergoing a change. So two elements from a single compound are undergoing oxidation and reduction. ठीक है? Then the third one that we did was disproportionation reaction. In disproportionation reaction, we had that one element from that compound in itself is getting oxidized also and reduced also. Now let's look at the other types. And did we do any other type? Yes, we did. Direct and indirect. So how can you forget about that? Direct is the one in which oxidation and reduction is happening in the same container. What is the heat energy? What is the energy liberated? It's heat energy. Okay, and then indirect is the one in which you have separate containers, and in that you generally use a solvent. So, and the energy that is generated is very good. Okay, now this is again something that you've done before. Types of reactions, combination reactions. You will be knowing all these terms. You've done it in 10th for your exams also. So you take 10th very seriously, I know. So combination reactions is the one in which two or more substances combine together to form a single compound, single substance or a compound. Then decomposition reactions, in which chemical reactions in which a compound breaks up into two or more simpler substances, that's known as your decomposition reactions. The third type is displacement reaction. Displacement is the one in which a more reactive element displaces the less reactive. Now this is something that you've been doing right from your 8th grade. The more reactive element displaces the less. Let's look at some of the examples of these. It's like more of a fun class today, because whatever you are doing is not that tough and it's very elementary, but very important from your future chemistry point of view, because oxidation numbers are now going to make you go into the pool and learn how to swim in chemistry. Okay, combination reactions first. Combination reactions. I'll just give you some examples for practice. And you just write down the oxidation number of each. CO2, Mg plus N2 is giving. So you will know what is getting oxidized and what is getting reduced now. ठीक है, अब तो सबको पता है कि ये 0 0 0 0 है सारे. And then you can find out the oxidation number of each of these elements and state which is getting oxidized and which is getting reduced. But in all these combination reactions are also a type of redox reactions, because your oxidation and reduction is happening in one particular reaction. Okay, and then you have say another one. Combination is generally to form a single substance. I am just taking it up as a separate example. Plus H2O. Alright, write down the oxidation number in each of the elements. Very simple, you can quickly do it. Then let's talk about the decomposition reactions. 2H2O is giving 2H2 plus O2. Then you have 2NaH is giving 2Na plus H2. Then you have 2KClO3. This we've already done. KClO3 then now that is an intramolecular redox reaction, which can also be called decomposition reaction. Decomposition, why? Because that element is getting broken into two or more substances and of its own. So that will be called KCl, that will be forming KCl and 3O2, right? And then now I think it's high time we discuss the oxidation numbers for all the reactions written on the board. CaCO3 gives CaO plus CO2. ठीक है? 0, 0, plus 4, minus 2. What is getting oxidized? Huh? सब बोलो. मतलब now please be spontaneous. I expect each one of you to be active now. This is like, is this other simple? I don't think we've done anything in our classes now. O2 is getting now converted to, so what is getting reduced? Oxygen. Okay, now here Mg 0, 0. This is like plus 2, and this will be like plus 6 plus 2x is equal to 0. That is how you will find how you will find out. Plus 6 plus 2x is equal to 0. So 2x is equal to minus 6, and x will be minus 3. So it will be minus 3. So this is like plus 2, and this is like minus 3. So what's happening to Mg? It's getting oxidized, and nitrogen is getting reduced. Okay. Now here. Minus 4 plus 1, 0, plus 4, minus 2, minus 2, plus 1. Anything happening to hydrogen? No. What's happening to oxygen? Oxygen is getting reduced. Carbon is getting oxidized. Okay. Decomposition reaction पे आते हैं. Plus 1, minus 2, 0, 0. Hydrogen is getting reduced. Oxygen is getting oxidized. Oh, earlier somebody said oxygen is getting oxidized and I had pinpointed. I'm sorry. That's how you learn. I'm also learning. You're also learning. But you have to give the IIT exam. I'm ahead of that stage. All right. NaH. Yeah. Minus 1 plus 1. 0, 0. So sodium is getting reduced and hydrogen is getting oxidized. This you know. Hydride minus 1. Metal hydrides, oxidation number rules. Simple, go through it once. You'll get full on full. Okay? Smile. Okay. Then you have CaCO3, find it out for this. You will have CO3 is generally 2 minus, carbonate hai. So CO3 2 minus, this will be plus 2, this will be minus 2. Or you can individually find it out also, so this will be like minus 2. So here your calcium is now becoming what? Plus 2. So calcium is just remaining the same, and this is minus 2. So how you link it to carbon then? In this particular case, then link it to carbon. In this particular case, what we have is CaCO3. It is like plus 2 minus 2. So carbon will be equal to, find it out for carbon here. It will be plus 2 minus 6 plus x is equal to 0. So carbon is in, ठीक है, क्योंकि और कुछ, let's see. So plus 2 plus 4 and minus 2. Here it's plus 2 minus 2, and in this case it is plus 4 minus 2. Nothing is happening. So this is not a redox reaction. So something has to get oxidized and something has to get reduced. So in this case it's nothing that is happening. I must have taken that example just like that. Okay, now let's move on to the next type. Combination done. Decomposition also done. And you know the meaning of these also. Now displacement reaction, let me just help you remind that a metal which is more active, or a metal which is more active or more reactive, can replace a lower active metal from its solution. This is what is more important. Like for example, if I have, let me just take up an example only. If I have a copper sulfate solution and I add zinc to it. Now because zinc is more reactive, it will form zinc sulfate plus copper. This you all remember. And if I add now copper to zinc sulfate, no reaction. Good. I repeat, if you have a reaction like CuSO4, this is your, I am talking about now, displacement reaction. In displacement reactions also you have two types. One is the metal displacement reaction, another is the non-metal displacement reaction. Now in displacement reaction you talk about copper sulfate and I did talk about zinc. So this will give you ZnSO4 plus copper. Alright, why? Because zinc is more reactive than copper. अब कैसे पता, ये तो पढ़ा है पहले. And let me just help you remember also. I think I noted it down also. Cbse Udaan. And then you have hydrogen, copper, silver, gold, platinum. I don't know where did I note that. It is Cbse Udaan. This you can remember. This is how I remember. Maybe you have a better way of doing some story. Kashinath ka whatever, you can just talk about it to your friends as well here. It's like PCS, Mazintal, then you have hydrogen and then copper, correct me if I'm wrong, silver, gold and you can have platinum. This is what you've done in the previous classes. That means if you're adding in the elemental form ye wala to a solution of any of the lower ones, then it will, the more reactive metal will displace it from its solution. Like for example, here you had a copper sulfate ka solution and you added zinc to it. So now what is zinc doing? Zinc is replacing Cu2 plus from its solution. But if you actually do ZnSO4 and then add copper to it, now because you know Zn is more reactive than copper, because you know Zn is more reactive than copper, this copper will not be able to replace Zn. तो ये याद रखना that a more reactive metal can displace a less reactive metal from its solution, not the other way around. Clear? So in this case there will be no reaction. Now let's talk about the oxidation states that we are doing. Write down the oxidation states for each of the elements. I'll put down some more examples. I think you can remember this, PCS Udaan. Please check up from your Kashinath story whether this is correct or not. PCS, Udaan, hydrogen, copper, silver, gold, platinum. Okay, so more reactive. Okay, let's write down. It's plus 2, plus 4, minus 2, each element I said. So this is 0. This is also again 0. And this zinc becomes now plus 2. Sulfur is like plus 4 only. And your this is minus 2. Oxygen is minus 2 only. So what is happening? Your zinc is getting oxidized plus 2 and copper is getting reduced to 0. So if you can segregate this reaction also, please now look up. Now one step ahead. This will be the next part of what I am going to do. But for the time being, I'll give you more examples also. इसको मैं दो parts में और लिख सकती हूँ. I know that my Cu is going from plus 2 to 0 state. So that means it is accepting electrons. Any doubts? And Zn, from Zn, let me go to the right hand side. It is becoming Zn2 plus 2 electrons. अभी मैं इसीलिए simple form में ले रही हूँ क्योंकि we'll be doing more complicated and balancing of the reactions also. So then Zn is forming Zn2 plus 2 electrons. When you take the net reaction will be Cu2 plus Zn is giving you Zn2 plus Cu. This is like your ionic equation. This is the balanced ionic equation. This is in the molecular form. This is in the ionic form. ये चीज समझ में आई कि हमने फोकस अब किस पे करा है, उन स्पीशीज पे जो ऑक्सीडाइज और रिड्यूस हो रही हैं. And in that I have seen that the one that takes up the electron is, what is gain of electrons? So therefore this is the reduction reaction. And what will this reaction be? This will be the oxidation reaction. तो मतलब इसी को मैंने अब segregate करके I have just shown it to you in another form. This will be helpful in understanding the cells. बात समझ में आई कि जैसे हमने ये simple reaction देखा, I know that in this copper is getting reduced and zinc is getting oxidized. So I have just written it down in terms of ionic forms that you can understand. तो एक reaction is reduction reaction, एक reaction is oxidation reaction. The balanced form of it when you total it up will be giving you the balanced ionic equation. ठीक है? Now let me just give you more examples of this. Some more examples can be, and now you complete the reaction. Okay, V2O5 plus 5Ca gives 2V. This is vanadium pentoxide plus 5Ca gives 2V plus 5CaO. I've just written because I did not put vanadium in the reactivity series. I can link it to the electrochemical series also, but I will do that in the next class. But remember this, please, this will help me in making you understand better in the next class, because we'll go one step ahead. This is 5CaO. What are the oxidation states? Find it out for vanadium. Plus 5, very good. Oxygen is -2. Calcium is 0. Vanadium now is 0, very good. This is, so calcium is getting oxidized and vanadium is getting reduced. This is simply your displacement reaction in which calcium is displacing your vanadium from its oxide. Then take another example, TiCl4 plus 2Mg is giving Ti. There are like the oxidation, the state of matter also given in each of the reactions. I'm just not putting that because Ti is solid plus 2 MgCl2. Alright, so here oxidation states +4, -1, 0, 0 and +2 and -1 of course. So titanium is getting reduced from +4 to 0 and magnesium is getting oxidized. Last example, Cr2O3 plus 2Al is getting converted to Al2O3, that is plus 2Cr. So Cr is in 0, Al2 will be +3 -2, this will be 0, and for chromium you can find out this will be +3 and this will be -2. 2x minus 6 is equal to 0, so chromium is +3. So chromium is going from +3 to 0 means chromium is getting reduced and aluminium is getting oxidized. Now this is one type of displacement reaction in which I am talking about the displacement of metals. So this is like the metal displacement reactions. Another type of displacement reaction are your non-metal displacement reactions. Write them down now. Non-metal displacement reactions. So now you have a clear-cut demarcation as to how to tell what is getting oxidized and what is getting reduced. And also now I expect each one of you to be able to distinguish between your reduction reaction separately, how the electrons are getting transferred, and oxidation reaction also separately. Okay. Now non-metal displacement reactions can be, you have 2Na plus 2H2O giving 2NaOH plus H2. That's like again a metal displacing a non-metal. What you have is, write down the oxidation state in each of these cases. Ca plus 2 water is giving CaOH twice plus H2. Alright, I'll cut it short. Just one more reaction. Otherwise, I have some 10 set of reactions that I've written. Fe2O3 plus 3H2. H2 in all the cases hydrogen is 0. Very good. Then you can have other reactions in which I am like quite confident that you will be able to write down the oxidation numbers and predict whether the reaction is, what is happening to the reaction. Can I just write some more and discuss them? See, sometimes there's one thing which is importantly given generally in redox reactions, like fluorine is a very electronegative element. You all know that it's most electronegative in nature. So it has the capability of attacking even water. So whenever you have like H2O plus F2, it generally reacts to form, I'll just put down the balanced reaction, to form 4HF plus O2. Alright, please remember this reaction, because it is because of this reaction that H2O plus 2F2 that you've written as 4, that gives 4HF plus O2, it indicates that fluorine is so reactive that it attacks even water. So that is why whenever we have to carry out the displacement of any of the halogens with fluorine, we never do it in aqueous media. This is like a question asked. Why do you not carry out the displacement of a halogen with fluorine in aqueous media? The reason is that in aqueous media, rather than reacting with your hydrogen chloride or hydrogen bromide, it would rather interact with water to carry out this redox reaction. And I call it redox because this is like plus 1, minus 2, 0. This will be minus 1, plus 1, 0. So in this, oxygen is actually getting oxidized to from minus 2 oxidation state to 0 oxidation state, and fluorine is getting reduced from 0 to minus 1 oxidation state. This is an example of non-metal displacement reaction, a pure example of non-metal. All reactions that we are doing are redox reactions. So here it's like a non-metal is getting replaced with another non-metal. Another can be like you can have Cl2 plus 2 KBr. This can be carried out in aqueous medium because this will not be interacting with water. So what will this give? I don't have to tell you. KCl plus Br2. Then you can have Cl2 plus Ki. Again balance the reaction. It will give you KCl plus I2. Alright. And remember that these reactions, like if I talk about this reaction, Cl2 plus 2 KBr, बहुत elementary concept है that you can write this as now 2 KCl plus, and this reaction can also be represented as Cl2 plus Br minus is giving you Br2 plus Cl minus. Now balance it out. So remember that for such reactions the charge always needs to be balanced. This is just the ionic representation. This reaction can also be represented by this, because it is the interaction of chlorine and bromine. इसमें we are concentrating at those species which are getting oxidized and reduced. Like for example, here Cl2 is 0 and here Cl is minus 1. So from 0 it is going to minus 1, and here Br is going from minus 1 state to 0. So that is what we are showing, that Br is going from minus 1 state to 0. Clear? What is individual oxidation state of O in OH minus? You tell me. You have OH minus here. Alright. So you will take it as X plus 1 is equal to minus 1. So X is equal to इसमें सब simple ही है. Okay. So let's talk about disproportionation reactions is also done. We've already talked about now different types of redox reactions. Just go through the different types of redox reactions that we've done. We have done intra and intermolecular and disproportionation reactions. Then we've also done with direct and indirect, and then you had combination, displacement, decomposition, and disproportionation is like another classification of this. Now let us see how to balance our reactions using this concept. This is a very interesting thing to do. Let's talk about the balancing. Now whenever we balance our reactions, redox reactions, there is a certain set of protocols that need to be followed. There are two methods. The first method, let's take it up, that's the ion electron method, in which we will be balancing our ions and electrons. So just carefully look onto the board and I'll just try and solve it. Say we are given a question, Cu plus HNO3, we are asked to balance this reaction. Cu plus HNO3 is giving CuNO3 twice plus NO plus water. We have to balance this reaction. Now in order to balance this reaction, the very first step, it's like stepwise, if what you have to do is write the redox reaction in ionic form. Now I just told you how to convert the molecular form into ionic form. जहाँ पे you feel that there will be an increase or decrease in oxidation number, how can you find it out? You can write down the oxidation state of each of the elements. लिखो जल्दी से, it will be 0, +1, -1 for the entire NO3 minus, otherwise for N it will be +5. Check it out, है ना? N will be +5. Then for copper nitrate also, and NO and H2O also. So in ionic form you can actually write this reaction as Cu plus H plus plus say NO3 minus. Let me just put it like that. Each thing, now Cu is getting converted to Cu2 plus NO plus H2O plus 2NO3 minus also can be put. Alright, basically your Cu is getting converted to Cu2 plus. Does the physical states of element affect the valencies and reactivity? See, the physical state of course will affect the valencies. How? Because see, valency क्या होती है? Valency है जैसे you have an element A. Understand the question. It's like just deviating a little bit from the topic, but I appreciate the question. It's like the physical state of an element. You have A as a normal element that you have. ठीक है? Now suddenly I heat that particular substance. What will happen to its electron? They will jump to a higher energy state. So it will have a tendency to lose electrons. So when it loses electrons, so what is happening to its oxidation state? A becomes A plus plus electrons. Just an example. So then it is changing the valency also. Valency हो गया, A से क्या हो गया? A plus. तो valency 0 से क्या हो गई? +1. So oxidation number change हो गया 0 से +1. उसको further heat करोगे तो हो सकता है 2 electrons भी निकल जाए. Depending upon the electronic configuration of your element, if I heat it further, then there is a chance that from A it becomes A2 plus now plus 2 electrons. So again the oxidation state changes. So physical state क्या होती है? The normal changes that we can heat, temperature, light, all these changes that we can bring about. Chemical changes are the ones that we are doing here. The intricate part of it, the oxidation number. So they definitely can affect the valencies and reactivity. Okay, coming back to this. Now in this, just check it out. Did you write down the oxidation numbers of each? You've written Cu was like 0, right? Your nitrogen was +5, +1 and -2 is like for hydrogen and oxygen. Now here Cu becomes +2, okay? And then for this it will be just NO3 minus in total, so +5 and -2 again, right? Here with me? NO में this becomes +2, -2 and -2 and +1. So water is like just generally saying. Now क्या +2 +1, this is done. Okay, so now the next step will be split the redox reaction into its oxidation half reaction and reduction half reaction. पहला step समझ में आया? पहले एक बार step wise करते हैं, फिर मैं एक ही बारी में जब total करूँगी ना, that will be absolutely clear. So what you have is Cu plus H plus plus NO3 minus. We've just taken out the ionic form from it. Now here in the second step I am asking you to segregate your oxidation reaction. So oxidation reaction क्या है? Cu going from, this is your oxidation. Here. ठीक है? So now what you have is, this is the oxidation part. What is getting reduced now? What is getting reduced? Cu is becoming +2. So Cu is getting oxidized. Clear. What is getting reduced? Nitrogen is going from +5 to क्या हो रहा है? So what is getting reduced? What is getting reduced? So here what we have is NO3 minus gets reduced And also you see that in this case what is happening, removal of oxygen is also there. So this will be my simple reduction reaction. तो next step में मैंने क्या करा, इन दोनों को separate out कर लिया separate out. Now balance the atoms of each half reactions by using simple multiples, and make sure that oxygen no need to take care of oxygen, make sure that the other elements are balanced. Like for example, इस केस में तो ज़रूरत ही नहीं थी, by chance the example that I had taken, Cu is 1, Cu is 1. Had it been Cu2 here, so I would have put a 2 here, क्योंकि I am balancing the atoms not the charges. ठीक है? Now here it is NO3. Now I will not be bothering about hydrogens and oxygens presently. I will just balance out the other atoms. So by chance nitrogen was 1 here and 1 here. So balanced, except hydrogens and oxygens we are balanced. So it is like balanced, we have NO3 minus to NO. Next, now balanced in the third step. In fact the fourth. Third may we balance atoms. Third may what will you do? You will be balancing atoms. And this is already balanced, so I am not writing it again. In the fourth step, you balance hydrogens and oxygens depending upon whether it is an acidic medium or an alkaline medium. ठीक है? Now balance hydrogens and oxygens. In the fourth step, you balance hydrogen and oxygen. How do you do that? Now you have, this is like, now let's talk about the acidic medium first. Acidic और न्यूट्रल मीडियम में कैसे करते हैं. Cu में तो कुछ बैलेंस करना ही नहीं ऑक्सीजन का. The only thing that you have is NO3 minus. So NO3 minus is giving you NO. Now जितने extra oxygen है on the other side, उतने add the number of water molecules here. ठीक है? Why are we adding onto the opposite side? Because you have a minus sign here. उसके opposite में you just add wherever you have extra oxygens, to the other side add whatever extra oxygens you had, that many number of water molecules. तो कितने extra oxygen है इसके पास? हाँ? एक्स्ट्रा कितने हैं? इसके पास 1 ऑलरेडी है, इसके पास 3 है, तो हमें कितने यहाँ पे ऑक्सीजन और ऐड करने चाहिए इन द फॉर्म ऑफ वाटर? 2. सो इट विल बी 2H2O. ठीक है? नाउ दिस इज 2H2O. I will balance now for the hydrogen atoms, and by adding H plus onto the other side, so I will get plus 4H plus. So what have I added? I have added this 4H plus and I have added this 2H2O. ठीक है? So this was my step 4. And अच्छा, step 4 में this was for the acidic medium. For the alkaline medium, for each excess of oxygen add one water molecule to the same side. And OH minus to the other side to balance H. We'll take up more examples to make you understand. I repeat it again. Had this, I've done it using the acidic medium, so I'm sticking to it. Had this been in the alkaline medium, तो alkaline medium में क्या करते हैं? जितने oxygen extra हैं, उतने we would have added water molecules to the same side and then balanced it with OH minus ions to the other side. Got it? Because it's in alkaline medium. So we would have taken it like that. Now add electrons to the side deficient of electrons. अब हम total कर सकते हैं. So now we'll add the electrons now. Add electrons means, let's talk about the reduction reaction, the oxidation reaction first. So Cu is giving Cu2 plus, तो electrons कहाँ add करूँ मैं? Plus 2 electrons, because plus 2 minus 2 on this side. So this will be Cu giving Cu2 plus 2 electrons. Now for the next case, next is your, let's copy 4H plus NO3 minus, क्योंकि now we are balancing out our charge. ठीक है? NO3 minus is giving NO plus 2H2O. अब now this is like, यहाँ पे तो 0 0 charge है, यहाँ पे plus 4 minus 1. Plus 4 minus 1 means इधर charge है अभी तक plus 3. So I have to balance this out by adding 3 electrons on this side. and moreover oxidation reaction will be loss of electrons and reduction reaction will be gain of electrons. So it's kind of a check for yourself. समझ में आ रहा है? Then in the next case what you have to look at the LCM. इन दोनों को हमें add करके electrons को cancel out कराना है. So electrons से cancel होंगे नहीं because you have 3 electrons here and 2 electrons here. So take the LCM and multiply it to get the LCM. So what will be the LCM of 3 and 2? 6. So multiply this reaction with, this will be the next step. This will be the step number 6. Multiply this reaction with 3 and this reaction with 2 and then add them. Okay? So now what we'll have in this case, you will have 3Cu giving, you just add it up and tell me the final equation. You got it, no? You will be multiplying the upper equation with 3 and the lower equation with 2. Okay, and then add the two equations to give a net equation, and your net equation will be, now write down the net equation, that will be 3Cu plus 2NO3 negative, very good, plus 8H plus, ठीक है, बस giving 3Cu2 plus 2NO plus 4H2O. Now this is your balanced ionic equation for the equation that you had seen at the initial go. कैसे? Let's quickly recapitulate. Look at all the steps. सबसे पहले हमने सबके ऑक्सीडेशन नंबर्स लिख लिए. एक बार ऑक्सीडेशन नंबर लिख लिए, हमने देखा कि कौन सा रिड्यूस हो रहा है और कौन सा ऑक्सीडाइज हो रहा है. Then we segregated only those parts, reducing वाला और oxidation वाला. फिर then we wrote the reduction reaction and we wrote the oxidation reaction. Once we wrote the reduction and the oxidation reaction, सबसे पहले we'll balance those atoms apart from hydrogen and oxygen. एक बार वो balance हो गए, then now we'll balance our hydrogen and oxygen by making use of the concept of whether it is acidic medium or alkaline medium. If it is acidic medium, I will be adding excess number of water molecules onto the other side where to balance out the oxygen atoms. ठीक है, फिर हाइड्रोजन को बैलेंस करने के लिए उतने H प्लस टू दी अदर साइड. ठीक है, इतने H प्लस हमने इस साइड पे ऐड कर दिए. अब हमने क्या करा, we took both the reactions together and added the electrons, charge balance किया by adding electrons wherever it was required, and as expected electrons for the oxidation reaction will be coming on the right only. This is like a check for you, verification whether you are going right or wrong. So you will add the electrons accordingly wherever it is required and then take the LCM, multiply it commonly and take the sum. This net equation is the balanced ionic equation. This is the balanced ionic equation. Now convert the ionic reaction into molecular by adding spectator ions. अब ये spectator ions क्या होते हैं? जिन्होंने participate नहीं करा but they were present there. Okay, so let me just put it like that. Convert the ionic reaction. The final equation is like this. Let me just check. 3Cu plus 2NO3 minus plus 8H plus is giving 3Cu2 plus 2NO plus 4H2O. Now, convert the ionic equation into molecular. This is last step, probably the 7th or the 8th. Matlab, you just have to follow the protocol. In this case, it will be, now let's add the spectator ions now. Let's see what is the spectator ions. Look into the main reaction once again and try to make it out for yourself. You have 3Cu plus 2NO3 minus, ठीक है, plus 8H plus 6NO3 minus. NO3 minus, I had missed something in the initial part. Do you remember where you told me to add the NO3 minus? So उस NO3 minus का as it is उस time पे कोई role नहीं था. But then they are there as a part of the total reaction. So I am adding 6 NO3 minus on this side, and you have 6 3Cu2 plus, because I had not put NO3 minus before. और हमने ये 6 choose करा है from the LCM factor, right? 6 NO3 plus, and this gives 3Cu2 plus 2 NO plus again 6 NO3 minus ions. Look here. Again you have the 6 NO3 minus here. अब उसको left right दोनों जगह पे लिख दिया तो it is not making any difference. Otherwise this reaction and this reaction would not have been the same. Left right दोनों जगह पे मैंने equal number of NO3 minus ions लिख दिए, so no issues. So plus 6 NO3 minus ions plus how many water? 4 H2O. And now the molecular form is easy. How do you write the molecular form now? 3 Cu plus 8 HNO3, 3 Cu plus 8 HNO3 is giving 8 HNO3 कैसे? You have 8, so now you got it? You have 8H and now 8 NO3 minus, so plus 8 HNO3. अब इसको यहाँ पे देखते हैं. Now this becomes 3 Cu, अपना basic equation देखो ना जो था, you had copper nitrate, so that was CuNO3 twice plus 2NO plus 4H2O. Done? Clear? This looks like a lengthy method, and now this looks like a lengthy method, but now I will just quickly show you कि इसको जल्दी जल्दी कैसे करते हैं. ये एक बार समझ में आया ना कि स्टेप वाइज हमने इधर उधर ये वो सब कैसे किया. अब let me just take up a common example and let's see how we can balance it quickly. What example should I take? Okay, oxidation of more salt using potassium dichromate. ठीक है? I am taking up the example that you will be performing in your practicals as well. Oxidation of more salt using potassium dichromate. More salt में your Fe2 plus gets oxidized to Fe3 plus. पहले ionic को balance करना सीखते हैं, फिर molecular तो अब समझ आ गया ना molecular में क्या करना है. Molecular is just getting back to the main reaction. Main reaction को देखो and then just add up your spectator ions. Spectator ions वो हैं which actually did not participate or make any difference, but equal number of them need to be added on either side. Okay, now Fe2 plus to Fe3 plus, and you have what is, I am saying using potassium dichromate. Did I say this? Potassium dichromate, and this gets converted to Cr2O3. So that means what is the oxidation state? Plus 2 minus 6 is equal to 0. So 2x plus 2x minus 6 is equal to 0. So what is your x? That will be equal to plus 3. ठीक है? तो इसका मतलब ये तो हो गया more salt का, मैंने आपको लिख दिया. You can easily find out the oxidation state of each and every element now. You can? ठीक है? Now I want all of you all to look onto the board. Copy it later. What you have is Fe2 plus is going to Fe3 plus, and you have your K2Cr2O7 going to Cr2O3. तो इस केस में मेरा अलग कर देते हैं इसका आयनिक फॉर्म, दैट इज Cr2O7. ये तो मैंने अलग पहले से ही लिख दिया, पूरा मोर सॉल्ट का फॉर्मूला लिख के कंफ्यूज नहीं करा. दिस विल बी Cr2O7 2 माइनस, क्योंकि K प्लस होता है, 2K हटा दिए तो K 2K प्लस प्लस Cr2O7 2 माइनस, एंड दिस इज गेटिंग कन्वर्टेड टू Cr3 plus. ठीक है? Here with me, all of you all keep giving me proper indications that you're listening. So here what you have is Cr2O7 2 minus is giving Cr3 plus. अब acidic medium, आज हमने acidic medium करा है. Let's talk about acidic medium only. जितने extra oxygen इधर हैं उतने यहाँ पे water molecules. ठीक है? कितने oxygen है? 2 Cr3 plus. Thank you. Okay, so this is Cr2O7 2 minus giving 2 Cr3 plus. Now here because it was Cr2O3 that I took. So I have to balance out the atoms before balancing my hydrogen and oxygen. So Cr2O7 2 minus will be giving 2Cr3 plus. This was my initial reaction. अब जितने extra oxygen इधर उतने water molecules on the other side. So what you have is 7H2O, right? So now the number of H ions will be added to the other side. So that will be plus 14 electrons. ठीक है? अब 14H plus. I'm really sorry. So shows that time is going to be up. What you have is Cr2O7 2 minus is getting converted to Cr3 plus 7H2O, क्योंकि जितने यहाँ पे oxygen उतने number of water molecules to the other side. So you have 7H2O here, right? अब जितने hydrogen इधर उतने hydrogen ions to the other side. So 14H plus. Now balance the charge with the electrons. So इधर total charge check करो, it will be 14 minus 2, that is 12. And what is the charge here? Plus 6. Total charge is plus 6. So that means इधर 12 है, इधर 6 है. I need to reduce here by 6 electrons. So this will be plus 6 electrons. Done with it? ठीक है? अब इधर Fe2 plus is going to Fe3 plus. इसके भी तो electrons balance करनी है. So plus 1 electron. So either it's 6, either it's 1. So the total of 1 and 6 can be 6. So just multiply the first reaction with 6 and you will get what? 6 Fe2 plus giving, add. So now add both the reactions. So you will have 6 Fe2 plus Cr2O7 2 minus plus 14H plus is giving 6 Fe3 plus 2 Cr3 plus 7 water. Clear? If this is done, all of you all before leaving from today's class, I can see the smiles. Do one last problem for me, that is oxidation of now the more salt from Fe2 plus to Fe3 plus using potassium permanganate. In that MnO4 minus is going to Mn2 plus. इसको करो balance. I am giving you both the ionic equations, right? One is an oxidation, the other is a reduction. So just write down the reactions for this. I write it again. I am talking about the oxidation of Fe2 plus more salt. So basically the species which is involved is getting converted from Fe2 plus to Fe3 plus, and you are using potassium permanganate. And I told you potassium permanganate will act as an oxidizing agent. What do you mean by oxidizing agent? जो खुद reduce होगा and साथ वाली species को it will oxidize. So NO4 minus is getting converted to Mn2 plus. I'll just check. I'm just giving 5 more seconds to solve this. 5 more. Now look up wherever you've done. MnO4 minus to Mn2 plus. First of all, let me balance manganese. Manganese is balanced. अब oxygen पे आते हैं. You have 4 oxygen here, so then 4 H2O here. Now H plus needs to be balanced, so 8 H idhar, so you will have 8 H plus on this side, right? Now 8 H plus हो गए. Now let's look at the charge. So plus 8 यहाँ पे total charge है plus 7, यहाँ पे total charge है plus 2. So that means I need to add how many? 5 electrons. If 5 electrons are added here, यहाँ पे भी electron, पहले electron add करेंगे, then you will be multiplying it with 5 and then you take the sum. So now the sum of both the reactions will be, you will have 5 Fe2 plus, as she was correctly pointing, plus MnO4 minus plus 8H plus is giving you 5 Fe3 plus Mn2 plus 4H2O. And tell me the oxidation state of Mn here. It is +7. From +7 it is getting reduced to +2, and so therefore it is itself getting reduced but oxidizing your iron from +2 to +3 state. Okay, from here we will continue and take up more problems in the next class. All the best. Thank you.